few little things I want to just draw a little rough sketch here. So we'll be doing graphing here. All right. And we'll draw as well too. Okay, we're going to talk briefly about the first derivative test. So I'll give you a second to write on too. So I think it's May the 5th. We'll do our first graph of the year, our first official graph. So exciting. It's been 3 months. So you're doing a graph over 3 months. So if you need to borrow a graph, I know, but that was official. It's like totally official. So, literally. Love it. First derivative test.
You're not on the tangent to begin with. You're just completely off the graph. Sort of like the box it gives us. You're that one line that passed.
Ready? Okay, so I'm just drawing a positive quadratic and a negative quadratic. Okay, now let's do. So what I'm drawing here is I'm drawing 2 tangents, and I'll do those in full lines so you can see. Those are 2 tangents that I'm supposed to be drawing on the first graph. All right, I'll give you a second to scroll that down, then I'm going to ask Callan an answer and a question. You'll hopefully give me the correct answer. Callan, what does f prime mean again? It's the slope of the tangent. I'll take later. Slope of the tangent. So on the left-hand side, you're not quite done yet, Callan, okay? On the left-hand side, when there's a minimum, will that slope be positive or negative? On the left-hand side. This one here. Is that going to be positive or negative? Negative. Right. So we're just going to say here, if I can draw it, that means f prime is less than 0, right? Does that make sense? It's going to be less than 0, it's going to be negative all the way across there, all the way from up to infinity, all the way down to just a little bit left. All right, so Tanner, you get the easy one. On the right-hand side, what's f prime going to be on the right-hand side? So what's the slope of this going to be? Positive. So we're just going to say f prime is greater than 0, right? Oops. Is there any time you can think of where there wouldn't be a local min or a local maximum when it would be, when you'd have f prime of x is equal to 0? When would you not have a local min or local max? Like a point of inflection. A point of inflection would be weird, okay? That would be a positive slope to positive slope or negative slope to negative slope, okay, right? But this is for these types of ones. And in the same way, I'll do this one. We're going to say f prime of x for a local maximum. I'll just draw a tangent, hopefully. And I'm going to say f prime is greater than 0. And over here, oh yuck, sorry, f prime is less than 0. Hope you guys get what I'm trying to say with that, though. Okay, right? We're just talking about the slopes on either side of the vertex. Is this what I sound like? It is what I sound like, isn't it?
No, Austin.
Do you want me to write that in a sentence so that helps with the end of the sentence? No, you're okay, Nathan? Do I go in anyone other than Nathan want to write the sentence? Nobody does? All right. Sample 1. We're going to say for the function f of x equals x4 minus 8x cubed plus 18x squared. Determine all the critical points then graph using an interval chart. Okay, there will definitely be graphs, in your future, 100%. There will also be, now you guys have forgotten, and I probably showed an example with factoring, higher or power things. We'll show you guys, remind you guys how to factor these things in a little bit. All right, Noah Solinger, you're up. Can you please be brave and take the derivative? Actually, why am I taking the derivative first of all, other than the fact I'm telling you to? What's the derivative going to tell me? Yeah, it's going to tell me more than that. It's going to tell me the critical numbers. It's going to tell me, right, where the graph changes, right, okay? But you're going to be brave and tell me please what f prime of x is equal to. Yeah. Yeah? Good. All right. Very good. Teresa, I'd like you to be brave. And we, of course, have to make this 0 equals. Okay, when I look at that question, I'm terrified. Teresa, tell me one thing I can do to make that look nicer. Okay, hold on. Give her a chance, please. Yes, what else? No, don't take the derivative. You're too much pressure. Okay, stop, guys. Just put your hands down for a second. Eagerness is you too. Okay, so they can all divide by 2. Is there anything else they can divide by? Yeah, 2x. I'm going to erase that. Just hold on a sec. Just wait. As soon as I do that, I see that's probably not right. Okay, that's close. So what else can I divide by, even still at this point? Another 2. So I'm just going to call that 4 and rewrite it. Okay. And you guys are in your eagerness. That turns to be x squared minus 6x plus 9. Yes, it does. So I chose this one properly. Okay, now just an x squared, so we can do the short form factoring. One sec. Austin will factor that for me. Austin, how do you do x squared minus 6x minus 9? What's that going to factor to instantly?
Well, you're going to have an x.
Good.
And you're going to have 2 negative 3's.
Yeah. Okay. Well, we can't. We'll just leave it like that. Is everyone okay with where that came from? Because I did that very, very quickly. When I say me, I mean Austin. Did that so quickly. Okay. Multiply. Sorry, go ahead.
I thought you divide by 4. So
You can divide by 4, but not by 4x, though, because the x you still need is a 0 root. We're only doing roots here in a minute. Okay, but 4x. What was I say? You can divide by 4 and just call it x bracket, but you need the you divide by 4, but you still need the x. Does that make sense?
Okay.
Chris, what are my zeros for this, please?
0 and 3.
Good. So x equals 0, and x equals 3. Okay. Chris, you're not done yet.
Okay.
What are those points? What are those?
They're the points that hit the first equation. Oh no, they're the slope for both tangents. Right?
You're guessing. You're wrong. Okay, I'm sorry.
Okay.
Somebody help me out. That came out wrong. I didn't mean to say that. I meant to say, I'm sorry, that's incorrect. Let's work together as a class to find a better answer here. What are those points actually? What are those points? Nate, I see your hand on this. Yeah, so these are going to be your potential, these are your local, these are your critical points, the x values of those, and that's going to be a local max or min. Okay, I still need to finish my critical points. I'm going to say,
How can you have 2 local maxes and mins?
no problem.
Oh right, yeah, sorry.
This is actually cubic, so it's going to look something like that.
Should have thought about it before asking the question.
Okay, my first one's going to be y equals f of 0 and y equals f of 3. All right. Uh-oh. Yeah, we're good. Okay. What does f of 0 equal? That's just 0. So my first one's going to be 0, comma 0. All right, f of 3 I can't do in my head though. 3, 9, 27, 81. I can't, I'm not even going to try. Can somebody help me?
I'll do that.
So you're plugging this into your original equation here, right?
Not the derivative.
Not the original equation, because the derivative should just give you 0, right?
I'll do it in my head.
Yeah, because that's way too big to do in, well, for most people. I'm sure there are still somebody that can do it in their head, but it's not.
I just don't want to.
Now, you guys should be tracking these two guys in the front, everybody should, because they pretend like they have the right answer, but they always just tell me that it's the right answer. Oh, because when I say, is this good? You always go, yep. Does this look good? Yep.
That's because I just worked.
27?
I got 27.
Okay. 327. So what I'm saying is, if I already graphed those 2 points, those will be the points that are going to be like a curve in the graph probably. Okay, that's what that's going to look like. Let's start to do an interval chart now to find out. Okay, so I do f of x. We're going to have a 4x and an x minus 3 squared. And then overall test shape. And I guess that's technically f prime of x, isn't it? Not f of x. Okay, 4b squared. What's my first interval going to be?
I have no idea.
Okay. Luke, do you want to try and help her? Okay, I'm going to help both you guys here, okay? What you're looking at here, Nicole and Luke, is that these are my 2 critical points, right? So that's going to be the 2 parts where it's 0. Whenever things are 0, that's a break. So the first one we're just going to say is to the left of this one, then the next is going to be between these 2, and the last one's going to be to the right of those 2, because that's the only when there's zeros. We want to always go negative infinity 0. I'm just going to call it x is less than 0. But if you want to call it negative infinity 0, go ahead. And then 0 to 3, and then x is bigger than 3. Okay, so it's always going to, your zeros are always what's important for an interval chart, no matter what type of interval chart you do, right? It's always going to be zeros. Okay, x is less than 0. I'm going to choose as negative 1. I'm going to call this 1. I'm going to call that 100. Okay, you can call it whatever you want. Okay, as long as it's in that range. All right, Derek. Can you please tell me 4 times negative 1 is going to be positive or negative?
Negative.
Negative 1 minus 3 squared is going to be positive. And a negative and a positive is a?
Negative.
Thank you. Now, before you're done, what does a negative shape on a graph look like? Downwards, okay? So it's going to, so less than 0, it's going to look like this. Okay? That was very, very fast, so I want to make sure everyone's followed with where that came from. We're all sort of okay? Nathan, we're good? Okay. Victoria. Oh, sorry, go ahead.
Okay. It's like, what's the number when the arrow goes down this way?
Well, there's only positive and negative, because you're always going left to right is all you're going, always on a graph. So it's either going to be a positive or a negative, because just to always go left to right. Like, all right, Victoria. 4 times 1 is positive.
And 1 minus 3 squared is also positive because it's squared.
Good. So the overall result is?
Positive.
Good. What does a positive graph look like?
Going up.
Okay. Matt, 4 times 100 is? 100 minus 3 squared is? Oh. Weird.
Is it going?
There will be some people that are going to always just say, I don't need the interval chart, Mr. Sadler. I'm just going to go positive, negative, positive, negative, positive, negative, positive. Because that's what always goes. I've just proven to you. I've just proven to you. I have just proven to you that you can't just always alternate. Okay, so it does actually matter to take the time. Okay, so what I'm going to do is this. I'm going to graph the points.
Your jokes, you might have like an 85.
Okay, so what I'm gonna do is I'm just gonna graph those 2 points that I have. In calculus, we're not gonna worry about zeros. Okay, we're not gonna worry about factoring the original graph, okay? All we're worried about is periods of max and min and all that. We're gonna get to like how the shapes curve and all that sort of stuff later on. So as far as original roots, like you learned in advanced functions, we're gonna leave out. Unless I ask for it, which I won't, okay? Because I just did an extra step, takes a lot longer. I'm more interested in the derivatives application of it, okay? So, you can do this on a piece of graph paper or in your notes, not on your desk, but I said that. You should never graph on your desk, no point.
Just reset
I think that's what he said. Somebody
You have
said.
too much time on your hands.
Okay, here we go.
That is a little. Okay.
It doesn't have to now and then actually do a graph in good because number one on your assignment and your test, I'll expect your graph to look like this. Okay. And let's not count by threes, let's count by
2.3.
oops. Now, this is a graph that you would not be able to do in advanced functions, okay, because there is only one zero. Okay? So, I'm going to give you a second to scribble. You're using Desmos, I hope you're using Desmos.
Yeah,
That's with Desmos.
maybe.
He definitely does knows.
Okay, but I'll show you what Desmos, I'll show you what Desmos will show you, okay?
That was suspicious as
So 0 and 0, I'm going to have 1 point. 3 and 27, I'm going to have another point, which is about here. Okay, now we already know this is, what type of graph is this?
A nice looking.
a wonderful, tremendous one.
Cubic.
Yeah, it's quartic.
Yeah. Well, oh, no, this.
Yes, it says quartic, yes, it
Yeah,
says quartic.
the original.
I was just about to have a heart attack there. I said, this doesn't work, but it does work, okay? Less than 0, what does my graph look like less than 0? Yeah, it's going downward. So it's going to look something like this, okay? This was scaring me because I thought it's not going to be a quartic. It is a quartic, okay? Now the trick is for this. It's going to go upwards and then upwards again. Now this is what Derek was, I sort of mentioned to Derek. I'm going to come back to you, Derek, if you don't mind. Remember when we said, if what happened if there was a triple root, what's it going to look like, you said?
It's a point of inflection.
It's point of inflection. So what do you call it? Like an L or a kick or something like that? A kick? So there's going to be a kick here, and we're going to talk about the point of inflection later on. Whoa, that's sort of bad looking. But that's sort of what it would look like. Not exactly, but it's going to look something. If you don't know right now, as long as you draw it, if you want to draw it like this today, that's fine. Okay, but that isn't what it's going to look like. There's going to be a kick to it. Okay, we'll show you how to find the kick in the next few days. Yes.
Because at that point, isn't it like a double root? So why, we have,
Well, because
aren't inflections,
yeah.
we don't.
We'll show you how the inflections work on Monday or Tuesday, but because it's going up and it's also going up again.
Fully right.
It's going up and then up again, right? So it's not going to bend. Well, the way you think, sort of imagine the one I'm going to think of. Imagine like it's going to be a parabola, but instead of bending over, you know what I mean? It goes upwards and like an upwards parabola, right? Like the left-hand side of this, the left-hand side of it should look like, you know, a parabola, and the right-hand side of that should look like an upwards parabola. If that makes any sense. Yes. So don't worry about this because we haven't really talked about it. But all you should know is that on between here and here, it's positive slope, right? Because that's what we did. And then from here to infinity, it's also positive slope.
Does this look right to
So
you?
why would you have to call it?
You could. You don't know. The thing is, the right answer is like this, but you don't know that yet. Okay, you'll learn about this on Monday. So that's what I was trying to say. If you drew a graph of this, as far as today's lesson, that's all you know how to do. That's okay. That's fine by me. Now, does that make sense with the positive to the positive? Let's talk about end behavior quickly for a sec. Going up to Nathan, I believe I'm up to you. Nathan, this is a positive x to the fourth. What's a positive x to the fourth supposed to look like? No, that's wrong.
That was a yawn. That was a yawn.
We'll get some more trouble. Well, positive x, let me help. What's a positive x to the fourth look like? Right? It's like a parabola, right? Like an x squared, so that's okay for that. I'm gonna write one for you guys to try, then I'm gonna hit pause in the video. Okay. Example 2. Somebody have a watch, please?
It is 9:56. You can't tell me that it's wrong.
9:56 to 23 seconds.
Well,
How do you know it's right?
yeah, how do you know?
I can take your hand 30 seconds and my watch is broken, so I can't. If I say 9:56 once,
Okay, this one's going a little bit backwards.
Me? Says you. What did I say about the name? The name is 5%.
Okay, so I'd like you to make a graph for me as best you can. I'll tell a joke in the meantime with those 3 conditions. Now this is just the opposite of what we just did. Okay, so it says the function is decreasing between 1 and 3 on the x values and increasing everywhere else. Number 2, that's your range. We're going from 0 to 6 on my range. And then the critical points are -1, 6 and 3, 1. Okay, so you can start in whatever order you want to. It might be good to say that, well, my graphs will go from -3 to 4 and 0 to 6. You can make yourself a little box if you need to, and then put your points. Critical points might be helpful to start with. Even though I listed them third.